when you have a reactant in excess, or actually a reagent in excess, because it won't react, then there's no need to do stoic twice. Just you already know what the limiting reagent is the stuff you're given. All right, so let's do it. 1.87 grams of, oh, hold on, we gotta balance this. Not good if we, all right. And this is a single replacement, okay? So these are not too bad. I can put sulfate together because I can see it's not going to change before or after the reaction. So just, in other words, I'm not putting S and O on different lines. All right, 1 aluminum, 1 copper, 1, 1, 1, 1. Oh man, we probably didn't even need to show our work. Let's just do it. We're halfway there. All right, so aluminum on the left side, we're going to multiply by 2. Let's do that last. It's all by itself. Right, let's do this one first. All right, sulfate, we need to multiply that by 3. All right, so put a 3 there. That means we need to update the copper. Well, copper was by itself too, so it didn't really matter. 3, and then copper goes there. 3. All right, now, well, aluminum is there. All right, so your coefficients are 2, 3, 1, and 3. Let me just take another look. Everything looks good. All right, so now we can do the stoichiometry. Let me pick. Let's go with blue. 1.87 grams of aluminum. 1.87 grams of aluminum. We're given grams, so that's no good. You want moles. Moles will let us convert between any substance. So let's get rid of grams of aluminum and turn that into moles of aluminum. Right. Let's get our answer needs to be in at least have 3 sig figs. So let's just report this. Yikers! Who figured that out? 20. Just go to 26.98. 26.98. All right, units cancel out. Now we can turn, now that we have moles, we can turn, actually I don't know if it's 1, so let me just start with the units. Moles of aluminum, 2. What are we looking for? Question is asking copper. All right, so copper, aluminum to copper is a 2 to 3 ratio, mole ratio, 2 to 3. 2 moles of aluminum will produce 3 moles of copper. 2 moles of aluminum will produce 3 moles of copper. Conversion factor. Cross out units. Now, final step, convert to the desired unit. Grams of copper. So we're gonna need grams of copper. Then you need the molar mass of copper. All right, so 1 mole of copper has a mass of 6,355. 6,355 grams copper. That's called the molar mass. Punch these numbers in. 1.87 divided by 26.98 times 3 divided by 2 times 63.55, 6.61 if we round to 6, what am I saying? 3 significant figures. All right, that's our theoretical yield, because this is automatically our limiting reagent. This right here is, because the other one is in excess, this is our limiting reagent that's going to lead to our theoretical yield. So now we can answer whatever percent yield questions they throw at us. What is the percent yield? All right, so no algebra needed, just plug and play. All right, we got the actual amount of copper that was produced is 4.65 grams. 4.65 grams. All right, so you put your actual over your theoretical, which is what we calculated. Multiply that by 100 to turn that ratio into a percent. .3% is the percent yield.